try to give you guys a good understanding of what data repositories are and look at some inspirational data repositories that are coming from our peers at other academic institutions. And then I'm hoping that you all take away some lessons learned from our experiences with launching a data repository at the University of Minnesota. So first, before we begin, I'd just like to get a little bit of information about who my audience is. So if everyone could think about these questions and raise your hand if you are currently working at an academic library. Okay, good. And could you tell me if you are currently offering research data services? Some kind of hands, some slower hands. I like it, okay. And can you tell me if you are running a data repository? Ah, okay, excellent. And then final question, for those of you who are running your data repository, do you do any data curation? Okay, yes, great, thank you. So that helps me a lot, and I think this is going to be a good fit. So first, I just wanted to explore just this idea of the word data repositories. This is a definition from the Research Data Alliance, their Foundations and Terminology Working Group. They have a growing dictionary of data-related terms, and this one is a very comprehensive one. But essentially what I wanted to establish was that data repositories are one component of the overall portfolio of research data services. This is one of many things that we could provide from an academic library, such as data management plan consultation, data management training and workshops, and then the actual archiving and preservation of research data in our repositories. Not all data repositories involve data curation. Some allow for self-submission, and then the data are just shared. And then other times you might curate data that goes into not your data repository, but maybe to a national repository, or maybe even a dark archive or storage location. Why are data repositories useful? Well, of course, there's a number of facets that researchers might need to actually, or motivations for researchers to share their data. And data repositories are really a nice answer to these sharing requirements. They allow researchers to share their data in a much more sustainable way, a much more persistent way, as opposed to maybe posting to a website or sharing your data via email. So data repositories can really support each of these motivations. So there are a number of reasons why people are increasingly required to share. Obviously, governments are requiring open data initiatives in a number of different ways. You saw this with the United States with Obama's Open Data Initiative for the government and asking the federal agencies to release their data for the public. There's been a lot of motivations because this actually helps democratize research data. So the idea that maybe wealthy institutions or wealthy countries only have access to some of this data is not really equitable. It doesn't really help facilitate our global understanding of science and research. Rather, we want to release our knowledge and make it accessible. There's also the idea that there's potential commercial value in some of these research data results. I'll refer you to the Australian National Data Service, which did a study on the data that were being conducted by their researchers but then left sitting on the hard drives. The idea that those data sets could have potential commercial value of millions, actually, they found, was really interesting and I think could be applied to other governments as well. Next, something we're all probably very familiar with are our federal funding agency requirements for data sharing. This classically comes out of the example of the Office of Science Technology Policy, which way back in 2013, going on 3 years now, asked all of our federal agencies to come up with plans to help the public gain access to both the research data and the research articles coming out of our federal grants. We're seeing some of the effects of that now as more agencies are releasing their policies in response to those requirements. We're also noticing that there is a need to release that research data, so it allows others to do new research on it. And effectively, I think the government is asking to see a return on their investment. We're funding your grant, we're helping you do all this great research. Now let's share that out with the discipline and with the community. Next, you'll see that many journals are asking researchers to share the underlying results, the data that is behind the charts and the graphs for those publications. This, of course, is going to help increase transparency and perhaps even facilitate reproducibility of those research results, which I think is really becoming much more of an important aspect in many different disciplines, which is great. And then finally, I think underlying all this is this shift in culture around data sharing. And there are a number of different drivers that I could guess are behind this. Mainly, digital data are much easier to share. And this really does increase the idea of being able to collaborate with researchers across different institutions, across different countries, and facilitate that reuse potential because of the digital nature of data. Researchers are seeing the impact of their efforts through the citation of their data sets, through increased citation of their articles when they are sharing their data sets. And this also is an idea around reputation building. If I'm a researcher who shares my data, who publishes and then also places the data out there for other people to verify, I am giving myself a good reputation. So that social impact of data sharing, I think, is really key. So data repositories, as I mentioned, can really help support all of these ideas in ways that will help data be shared, but also in more sustainable and curated ways. So I'm going to go through different types of data repositories first, before we look more specifically at institutional data repositories. The first category I'm calling disciplinary data repositories. And this could also be known as a subject data repository. I might even call a national data repository in some of these categories, because we're talking about data repositories that recruit and accept data of a homogeneous nature oftentimes. The data sets are anticipated of a particular type or file format based on that discipline's experiences. And so you've got well-known data repositories that have been around for many decades, like the ICPSR, that is collecting social science research, survey data, political science research. Dryad, which is running the same platform that we're running at University of Minnesota on DSpace, where they are collecting data that actually support journal articles. So they have a very wonderful partnership with journals where once you submit your journal article to the publication, you also have this parallel submission process for the data set that goes into Dryad. I really like that approach. I like that the data is separate from the journal itself. Of course, you've got more particular focused data repositories like GenBank and NOAA, the Climate Change Data Center, where you've got maybe even more of a wider variety of data sets, but it's all around a particular discipline, so it has a general theme. There are many, many more data repositories of this nature, and I point out re3data.org, which is, of course, the repository for data repositories, if you will, where you can search across over 1,500 data repositories by subject and keyword. So the other facet, I guess, or type of data repository I want to point out are general data repositories. So general data repositories, I think, is a really interesting concept that we've seen pop up over the last few years, where they are open for anybody to deposit their data into. So they're not necessarily subject affiliated, they're not necessarily institutionally affiliated, they're open for anyone to deposit. So figshare.com I think is really probably the most well-known example where you can upload your data, you can even get your DOI for that data set, and it's available on the web. Zenodo is another example coming out of Europe. Similar design, you sign up, you upload your data, and it's available. Of course, Mendeley came out with theirs last year too, because they need to get in the game. So Mendeley data is another option for people. As you can see, the landscape is becoming quite complex. Dataverse also allows anyone to upload their data. There's an open collection where you can go and deposit. ICPSR has an open collection now. You don't have to be a member to deposit your data. And then Open Science Framework, not necessarily a data repository, but it can be used as a data repository. It's much more like a collaboration space where researchers can come together, share their data, but then also publish that data. And it connects to things like GitHub, which was also another way to publish your data. So lots and lots of growing areas to really share the long tail of data. Now, I'd like to make the argument, though, that the institutions where our researchers are affiliated with really are the best home for the research data that they're generating. We have an institutional commitment to manage and preserve the outputs of our universities and our academic centers and other institutes. And I think it's really the most appropriate place for the long-term stewardship of research data as well. So I'd like to point out some of the different types of institutional data repositories. And you'll note here that I've got a list of the different types of technologies that each of these institutional data repositories are running. So I'd like to show some examples. These are some inspirational data repositories that I like to look to. I don't want to emphasize too much on the technology side. I don't think technology is the end-all be-all to data repositories. It's actually one of the easiest components, I think, of starting out your data repository. All the other stuff we'll get to in a minute, but just for fun, I wanted to show the different flavors. So this first one, if you haven't noticed already, is the Harvard-Smithsonian Center for Astrophysics, where they are running Dataverse, which is a really excellent platform built around research data, has a very extensive metadata profile, and I think a lot of really great features that is very well built for data sets and data set submission process. But you don't have to have a custom underlying infrastructure to build a data repository. This is Washington University in St. Louis, where they're using bpress for their data repository. And you'll see here that they are collecting data sets in the same way that you would collect your articles and your publications using bpress, but they have the underlying support of that fee-based infrastructure, which is really nice to know you have a phone call away from tech support. Other examples, which this one just looks amazing in my opinion, is the data repository for the University of Minnesota. This is running on DSpace, and I'll talk a lot more about this in a minute. But if you're familiar with the DSpace technology, this is actually a collection in our bigger institutional repository. So it's just one of 600 collections, but we rebranded it to be a data repository that we could promote. ePrints, one of the most widely used platforms for institutional repositories, is also being used as a data repository. And this is the University of Bath, which has some really nice policies and other tools that I would encourage you to take a look at. Fedora, the open source software, is being used as well. The Rutgers University RU Research Data Portal is built on top of Fedora. They have their own software that they've developed, and I believe is open source, that you can go and read more about on their website. HubZero is a technology that Purdue University developed, and PUR, the Purdue University Research Repository, is a really excellent example. I think PUR goes beyond some of the other data repository examples that I've shown in the fact that it also allows researchers to create their own collection of data that may not be publicly available, where you can create and manage a data set, maybe share it with one or two other people, but not actually publish it more broadly. Whereas I think many of the other systems that I'm showing you is much more of a workflow that is going to push you out on the publication and data sharing side pretty quickly. Hydra is a very hot technology in the developer world, and I think the Scholarsphere from Penn State is a good example of why. They are using, this is an institutional repository model that also accepts research data, which as someone who runs an institutional repository and a data repository, I find that very convenient. It's very often that I will work with faculty. They don't just have one or the other, they have both. And so being able to sort of slosh things across the different repository sides based on the type is really convenient. So I can appreciate that. And then Islandora is another open source platform. This is the Simon Fraser University that is running it for their data repository. So I hope that gives you kind of a potpourri of different technologies and types. But I want to talk a little bit more about what we think about when we're building an institutional data repository. So I am showing you here the stool, the wonderful three-legged stool from Nancy McGovern. And this is her model for digital preservation. And that underlying digital preservation framework, I think, works very well for research data repositories, because we do need all the same things. We need the technology infrastructure, we need the underlying software, we need the storage, we need that security, that backup. The organizational layer, which I think is definitely the most important component, where we have the commitment from our organization. We have the acknowledgement that we are introducing a service that is not just a 1 or 2 year pilot. This is a repository that will aim to be around for a long time. We are aiming to preserve digital materials, and we need to make good on those commitments. So this is not something that we want to undertake lightly. And then finally, the resources leg. This is where our staffing and our funding and our training come in, where we need to have the support of the people and the money to continue to provide these services in the coming years. So with that in mind, I think you got a preview of it earlier, but I'm not saying that my data repository is broken, but I don't think we have it all figured out yet. And sometimes it feels like somebody kind of chucked my resources leg across the room, and you have to go find it. But I think the data repository model can really build from these 3 legs. And so that's what I'm going to try to do here, and go into a little bit of a deep dive on how we built the data repository for the University of Minnesota. So just a quick overview. We launched in November of 2014. It is an open access data repository, open to University of Minnesota affiliates, staff, students, or faculty. We mint persistent identifiers for all the data sets using DOIs. All the data that goes through, that are accepted, goes through a curatorial review, and I'll talk a little bit more about what that means in a bit. We provide people with the option to add licenses, Creative Commons licenses, and we're flexible on that. We also provide download statistics that helps as a reuse indicator, and we have a commitment to preserve the digital files. And our preservation commitment is for at least 10 years. And this was a conscious decision on ourselves that indefinitely is really not a reasonable number anymore. And I don't think that anything is going to happen to these files in 10 years. I can't imagine somebody just sitting there with the delete button waiting for that time period to end. But we had to come up with something that was realistic for our institution. So looking at the 3 legs of the stool, let's first start on the most important leg, as I mentioned, the organizational infrastructure. So the libraries made a commitment in 2014 with a data management and curation initiative. This was an initiative that really said that we're setting aside resources, we're setting aside people's time to dedicate to this and to produce research data management and curation services for the libraries. Our first task, I was able to lead a 19-person team, and part of the team was the development team for the repository. The other part was the service and policy side, where we first developed a business model. And I really do contribute a lot of what is included in this business model to our project manager, who was completing her master's in business at the time. She had a lot of really great ideas to bring into this business model, which included doing a SIPOC analysis of how much time and effort it might take for each of the different services we were suggesting, as well as coming up with a number of different plans for staffing and a number of different ways that we might actually implement this service using good business techniques. Policies was another key outcome that are included in that service model. We really needed to define well before we implemented the infrastructure what kind of data we would accept, what were our limitations, and let's acknowledge those limitations. So for example, the data repository has an upload file size limit of 2 gigabytes per file. This is a browser limitation that we've discovered when you're uploading data through a web-based system. It will time out. And so we instituted this policy. We have other policies around what kind of data you can deposit. We do not accept data with personal identifiable information, for example. Not just the policies, though, but we had to also think about procedures that would help us ensure that those policies are enacted. And I'll talk a little bit about that in a minute. The data repository itself fits within a portfolio of data services that follow the research data lifecycle, kind of shown here in the flow of this river. I just wanted to illustrate that the data repository might be kind of that end stream type service, but we are definitely trying to get up in the earlier phases of the stream and work with researchers when they're doing their data management plans, when they're looking for support for different storage options on campus. We're making referrals, we're working with our OIT, we're working with our sponsored projects administration. So it's really much more of a lifecycle model. It's not just a standalone service. Another thing that we really heavily built on was our existing libraries digital preservation framework. Again, going back to Nancy McGovern, who has a framework that you too can institute at your institution if you have not already. We built from that and developed and set out really a framework for how we preserve digital objects in the library. And these aren't not just for the data repository, but for all of our digital objects that are coming into our institution repository, that are coming into our special collections, that are coming into our archives. And this really gives us a framework to build on of what kind of institutional commitments that we are able to make. I'm also very lucky to work at a university that has a research data management policy, and that the libraries were invited at the beginning on this policy planning committee to help create. This policy rolled out in 2015, January 2015, and it really outlines the roles and the responsibilities of different units on campus, including the libraries, and it defines our role in digital data stewardship and as well as data management training. So this was extremely beneficial, I think, for us and for others on campus to have a better understanding of where each of our different services intersect and who has primacy over the different support structures. Marketing and promotion is another key organizational aspect, and this is something you will continue to do after you launch your data repository. This is not just a one-time thing, but this example here, relating back to the policy, after the data management policy went into effect, our vice president for research and our university librarian collaborated to send out an email to faculty really announcing the service and referencing the policy and saying, we're not just putting out a policy and asking you to preserve your data on your own, there are services in place to help support this policy. So this was really good timing as we were able to roll those out pretty simultaneously. Technical infrastructure, the technical leg. So as I mentioned, Drum is running on our existing IR. The IR has been up and running since 2007. We're using DSpace. We did a really good job, I think, on the theming layer to make it look like we're not using DSpace. But I think really, I can't say enough. I mean, DSpace, it has all the right pieces. It's all there. I mean, you don't have to build your own workflow. You don't have to build your own email notification system. It's all kind of there. It's just kind of hard to make it all work together sometimes, but we do, we strive. And so the data repository collection is just one component of DSpace in our entire IR. We did do a number of modifications, however, and the metadata schema was one thing. We expanded our metadata profile for the data repository collection. So we're using the Dublin core, but we're expanding it to include metadata elements that are more appropriate for research data, like the geospatial coordinates, the temporal components. We've got a number of different temporal components. And then we actually require that researchers include a contact name and email address because we're also finding that users of the data may have questions, and the repository is not the best place to answer those questions. As I mentioned earlier, the collection homepage is also branded so that we could have a focal point to promote on campus. We had 99 functional requirements for the research data repository. The most important one for me was that the words data repository was up at the top. And it's really incredible. I mean, I've been working with the IR since 2012, and we have lots of data in the institution repository. We've got over, like 600, 700 data sets that have just kind of, been collected over the years. But it's really difficult to talk to researchers about data and about the IR without this type of branding. And I've really found this to be a facilitation tool to have those words at the top and to really demonstrate that this is the appropriate home for your research data. Also, the record views were adapted for the data sets as well. We found the data sets were a little bit more complex than the rest of the objects that we keep in the IR, and so those views were adapted, and we did some usability testing to try to figure out the best way to present the record to our users. We also provide researchers with a boilerplate of information that they can use to include Drum in their data management plan. And this text includes information about the way that Drum stores data sets, the way that we back up the data sets, and the security around it, as well as information about the preservation tasks that we undertake with the repository. So it helps to meet all of the different requirements that you might see in a research or in a data management plan, but we're providing that to them in a template form. The curation aspects of Drum are very key. All data sets that come into the data repository do go through a curatorial review, which means we open up the files, we look at the data, we try to understand the data, and we ask the researcher questions like, I see that you've got all these acronyms in your header file. Why don't we figure out what those mean and write those down? So it's really not very difficult. It's really just looking at the data with a fresh set of eyes and asking questions and then working with them to document the answers to those questions. So we're able to find incongruities with the data, missing data files, incorrect data files, information like, why do you have blank spaces? Well, in this file, I have blank spaces because of this, but over here, I have blank spaces because of that. Oh, I see. Okay, let's write that down. So it's very fascinating, and actually it's very rewarding. It's very fun to work with researchers at such a level because you're coming at it with your curatorial expertise. You're coming at it as a librarian, as an archivist, as someone who is going to hear those questions echo in the future of, how do I use this data set? And you're able to apply that knowledge, that skill set in such a way that really benefits the researcher. You're enriching their data set. You're making it publication ready. So we do things like look for sensitive information. We do try to back up our policy and make sure that people aren't depositing data that has any federally protected information or legally protected information. Our system that we're using a couple different tools. This one is Identity Finder. We also use a tool called Bulk Extractor. They are not magic. They're not perfect. They won't pick out, personal names. But they do help us try to identify any red flags or allow us to figure out if we need to really dig deeper and look further before accepting data into our repository. Another major thing that we do, and I'd say very often, is help researchers create documentation for their data. Data sets are generated by many researchers without the idea that somebody else is going to use them later on. So that idea of data documentation for their own personal use might not translate well into a data repository setting. For that, we've created a data repository, the README template. This is a template that we adapted from Cornell University, and it includes a bunch of different triggers to help address certain questions like what was your methodology, please define your headers, let's create a data dictionary together. And we fill it out for them as best we can based on their submission, and then we send them an email with a list of targeted questions to help fill in the answers that we couldn't identify. And then next, we also do a lot of data file format transformations. This is purely, or mainly for preservation purposes. So when we'll ingest file formats that maybe are proprietary, we'll try to identify and research ways that we can export those files into a non-proprietary version for preservation purposes, as well as for use purposes. For example, whenever we get an Excel data set, we'll actually archive an archival version is what we're calling it. We built a tool called the Excel archival tool that takes Excel worksheets and actually exports them into XML files. It captures the images, it captures the graphs, it captures the formulas, and it packages them all up into a zip. And if you've ever opened up an Excel file that had 60 work tabs at the bottom, you know that doing this by hand would be very time-consuming. So this tool automates all of that, and our graduate student that developed it posted it freely available on GitHub as well. The next leg is our resources infrastructure. And in this area, we have staff and we have monetary support. One of the only key monetary support things that we asked for in our business model was for support to purchase DataSite, a subscription to DataSite DOIs. And that really has allowed us to mint DOIs for each data set. It also feeds our metadata for each data set back into the DataSite search interface. And that in turn feeds into the Web of Science data citation index. So we are facilitating the abstract indexing of all of our data sets in the repository, as well as, we get hit by Google and Google Scholar and all of those areas as well. Our staffing model for the curation aspects, we've got a number of data curators who work in the libraries, and then we also work with our College of Liberal Arts. They hired a data management specialist, and it's been really great to work with the data management specialist in the college. She's actually a part of our team. I kicked her a data submission just yesterday because she's really involved in more of the earlier phases of the research lifecycle for her researchers, and being a part of our team has really built up stronger relations with the college in a number of ways. Other folks on my team, I've got a graduate assistant who's hired at 50% time, who is our scientific data curator, and this role is really key. Most of the data sets that we receive come from the sciences, and I'll be presenting a poster where you can see more of the statistics of running Drum for the last 2 years. But essentially, her role is not just to curate the data sets of known formats, but to research unknown data file formats and to better understand, gosh, we've never seen this data file format before. What is it? What kind of software is needed to run it? How can we preserve it? And so that's been a really, it's been a fun challenge, and it's really kind of exciting to be able to add those to our procedures as we run into them, because you just can't anticipate all the file formats you're going to receive with your repository, but you can learn from each experience. We also have a social sciences data curator, and these are all library staff members that are donating 10% of their time or 20% of their time, depending on who they are. We have a digital arts and humanities specialist who works on our team, a health sciences and public health data curator that we just hired. We initially did not want to roll out our data repository to all of the clinicians at first. University of Minnesota has a very large medical school, and we've got about as many clinicians as we do faculty. And so this was anticipated as perhaps a need, but certainly there are other places where data from the medical sciences need to go. And so we actually do also have on our campus a clinical data repository that we refer to people whenever possible. But there are lots of other researchers on our campus that we know are working with human subjects data and de-identified subjects data. So we know that there is definitely a need for data sharing in those areas, and we're really hoping to ramp up support for that. And then our GIS spatial data curator, which I could not live without. I really appreciate the way that he can open up a GIS data file and know instantly that, oh, well, their codes are missing. And I'm like, oh, great. Don't know what those codes are, but wonderful. Let's get those codes. And it's a really great experience to have a team that is all bringing together a different set of expertise that is very complementary in a way. And we meet on a biweekly basis. We have a stand-up meeting where we share our experiences with each data set. So we're actually able to learn where were the pitfalls and where were the challenges for each different data type, and kind of share that knowledge with each other. When we do get new training, when we get new data curators, we have a training procedure that they go through. They have 18 activities that they walk through that simulate the data curation process at various stages. And this allows them to really kind of immerse themselves in the culture of data curation and really kind of trying to establish best practices as we go along. That's part of the reason why I'm working on this book for ACRL, this Curating Research Data book, bringing together the best practices from over 40 different specialists at different data repositories, both disciplinary data repositories and institutional data repositories, so that we can really share and learn from each other, because there's not a lot of best practices really nailed down out there. And I definitely hope that we're contributing to this process as we learn and curate new different types of data. So as we are ready to head to lunch, I will close quickly. Why we build data repositories. I really can't say enough. It really gives you a great exposure on campus. Having a data repository, and I've been at the University of Minnesota for about 8 years, I've definitely seen the shift of those conversations. Drum has been invited to be on grant proposals, large infrastructure grants, just because of the name Drum, I believe. and having an opportunity to sit at the table and have discussions about what we're going to do with big data, and should we purchase Globus, and should we purchase Box for sensitive data storage, and having those collaborations, it's really helped and changed things at the campus level. And also, as I mentioned earlier, it's extremely rewarding to partner with researchers to share their experiences in publishing the research data, and to really add value to the data sets that are coming across our desks, and to be able to enrich them in such a way that I believe will make them more reusable in the long term. So with that, I just want to encourage you to build your own stools. Thank you.